All right, well, welcome back, guys. Of course, we had a little trouble during the last attempted lecture. I think what happened, I went back and I looked at the video. I think what happened there was a couple of things. Number one, I didn't have the projector on. When the projector's not on, I can't communicate with you. I think you guys can see me. I don't know if you can hear me. But also, somebody had their mic not muted. And when you have your mic open, once if you make a sound, it cuts from me to another, to whoever's mic is open. I think it was a combination of those two issues that caused us to have a problem in the last class. But I went back and looked at the video, and even though there was a chunk of it that was cut out, I think it was enough of the video in there for you to kind of see what was going on with the circuit. So that's the reason I sent out the link and I posted it to YouTube, so you can go back and look at that. Both sections should have access to it. So I think it'll be okay. What I want to do today is to continue on with the sheet that we went over last time, that topic sheet. There were two problems. The first one at the top is the one that we worked on when the camera went down. The one I have on the board now is the second of the two problems that I want to do in class. And the rest of the problems you'll do for a homework assignment. Now, the homework on the bottom of the paper is listed as homework number 6. It's listed as homework number 6, but I haven't given you homework 5. I haven't given you homework 4. So even though it's listed as homework number 6, there's some other things coming that I really should have done before this, but because of the situation with our copier, I'm unable to print right now, but it'll work out. So just kind of right now, don't worry about the homework number, and I'll get that straight when I'm able to provide you with some more documents. What I want you to do is to make sure you have pen or pencil, paper, calculator, and your coloring pens or pencils. And this is the problem figure 6-7 on the topic sheet. I want you to apply the method that we talked about in the last couple classes and see if you can solve this. I want the voltage across each resistor and the current through each resistor. So we'll do this, and this will be the two off the homework sheet, off the topic sheet that I'll do. And I want to show you one more technique for solving the circuit that might not be easily recognizable, what's in series and what's in parallel. I'm going to show you a technique to solve a circuit like that. So I'm going to pause for a minute. You see what you can do with this problem. Just to kind of walk back and think about the steps to solving this. You want to start with the part of the circuit furthest away from the voltage source. You want to identify any nodes. You want to start combining things that are easily recognizable to be combined. And you want to eventually end up with a series circuit. And then you'll use that series circuit to solve the more complex circuit. So you've seen it a couple times now. See what you can do with this. I'll give you a few minutes to kind of get into the analysis, and then I'll come up and we'll slowly work our way through it. So see what you can do with it, and then we'll talk about it in a few minutes. Okay, you guys can keep working, but I just want to kind of get this started. So what I'm going to do is I'm going to start from the part of the circuit furthest away from the voltage source. The voltage source is on the left. I'm going to start on the right. I'm going to identify my nodes. So I got a node here. I got one at the bottom. We'll name them A and B. And then I want to start combining resistors. And what I want to ultimately end up with is a series circuit. Now, in the previous couple examples, we were able to go from the original circuit right to the series circuit. I'm going to do this one in a couple steps. We're going to need probably 2 circuits. You don't have to do it this way. You can combine this and go right to the series circuit. What I find is the more pictures you draw, the less you got to think about it when you try to solve the actual circuit. So I advise just kind of doing it stepwise and drawing as many pictures as you can do that, as you can. So in other words, instead of combining these and then combining the 2 branches in parallel, I'm just going to combine R2 and R3. During series, I'm going to combine those 2 into this one. And during series, total branch resistance here would be 4 and 2, which is 6. So this is 6. And I'm going to name this resistor. If they were in parallel, I would name them R3 parallel R2. Since they're in series, I'm going to name it R3 or R2, R3 plus R2. So this is R2 plus R3. That's how I got that. So you want to put that information there. And then, of course, I got R4 right here. It's 2K. R1, 1K. And then what I want to do is move my node information over to this diagram. Node A, and this picture is over here. And node B is down here. So now this picture is something similar to what we've been doing in the previous couple example problems. Now we can go from this right to the series circuit. So again, I don't know, you might have went from here right to the series, but again, I recommend, you put in as many steps in here as you can. It just makes the problem easier to solve. But if you got to this point, I'm going to pause again and let you draw the series circuit and keep doing your analysis, and I'll be back in a minute. All right. Now I'm going to continue to draw the series circuit. Let me see if I can fit this in here. I don't have a lot of board space. I think the camera cuts off about right here. So I'm going to try to squeeze this in here. Hopefully you can see this in the camera. Okay, so here's R1. Now what I'm going to do is combine these two. And this is, I'll write it down here. This will be R2 plus R3. Since that makes up one resistor, I'm going to put that in parentheses. And this value right here is in parallel with R4, which is 2K. So basically, I have 6 parallel, got 6 in parallel 2. So I can use my product over the sum or 1 over R rule to that. We'll do that in just a second. This is 1 kilo ohm. My node A is right here, and node B is right there. So I'm going to just move my node information over to my series circuit. So this is A, that's B. Now we got to figure out, well, I got my 25 volts. Put that in there. 25 volts. Now I got to figure out what this is. So I can use product over the sum. If I use product over the sum, I get 6 times 2 over 6 plus 2. On the top, it gives me 12. On the bottom, it gives me 8. What is that? Anybody? 12 on 8 is what?
1.5 kilo ohms.
1.5. Thank you. 1.5 K ohms. I think my camera cuts off about right here, so hopefully you guys can see that. So notice.
It's still in there.
Say it again.
It's still in there. You're good.
Okay, thank you. So notice what I'm trying to do here. Again, I'm trying to draw as many pictures as I can. When it's convenient to go right to the series circuit, it's okay to do that. When I start having branches in there, parallel branches to have other resistors in series in a branch, I'm going to draw more than one picture. You'll see what that does for us when we work our way back. It's going to make it really easy to do. Much easier to do if you went from here right to here. Now, I'm going to give you a few more minutes, and I want you to go ahead and solve the series circuit. Move the information over to here, solve this circuit, and then move the information over to here. While you do that, I'm going to clean the board up a little bit. Get rid of some of this stuff. All right, so see if you can solve it and move your information back over, and then we'll jump to that other example problem when we're done with this. Okay, so let's go ahead and solve this. So I have a series circuit, and when I know all the values in the series circuit, there's several steps I go through. That's the same for any and every series circuit. I first find my total resistance, and for this circuit, my total resistance is 1K plus 1.5K. Total resistance 2.5K ohm. And then I use that total resistance to find my current. Using Ohm's law, current is voltage over resistance. So my current is equal to, excuse me, 1 second. How is that happening? Okay. So my current is equal to voltage over resistance. I have 25 volts. My total resistance is 2.5K. I'm going to leave the K there because remember, if I have K on the bottom, that just means my current is going to be in milliamps. And what I'm going to do is divide 25 by 2.5. Anybody got a calculator handy? What is 25 divided by 2.5?
That'll be 10.
10 milliamps. 10 milliamps. So what I'm going to do is using another color. I use green for my nodes. I'm going to use, I'll use the blue. We'll see how well the blue shows up. We'll use blue for current. And in this circuit, I'm going to show a 10 milliamps coming out of the battery. 10 milliamps. I like to put a box around my currents and circle around my voltage values. But once you do that in the series circuit, the current in the series circuit becomes the main line current in all the other circuits. So the main line is the ones connected directly to the battery. So if I have 10 milliamps here and all the rest of the circuits down the line, I got to show 10 milliamps coming out the battery. So I'm going to erase my calculations. I'm going to show that 10 milliamps right here coming out of the battery for this diagram. And then the same over here. And I'll come back over here and see what else I can find. Well, the only thing left to find would be voltage drop across each resistor. And to find voltage drops, I take the voltage, I take the current through the resistor times the value of the resistor for each resistor in question. I'm going to use red for my voltage. So if I take 10 milliamps times 1K, remember if I multiply milli and K, they cancel out. So I can just multiply the 10 times the 1. This will give me 10 volts across R1. I want to show it in every diagram. 10 volts across R1 here. And then 10 volts across R1 here. And then over here, I can do the same thing. I got a choice now, right? I can either do 10 times the 1.5, or I can apply Kirchhoff's voltage law, which says that if I have 25 volts across the whole network, I'm dropping 10 across the first resistor. This voltage plus this voltage has to equal 25. So this voltage right here has to be 15. But that 15 volts actually goes from node A to node B. That's a special voltage when it goes across a node, because what that means is in the other diagrams, we got stuff in parallel, and those parallel branches will all get that 15 volts. So when I move this information over to here, I got 15 volts going from node A to node B. That means this branch gets 15 volts and this branch gets 15 volts. And over here, I'm going to show the same thing. I got 15 volts going from node A to node B. I look at this circuit, notice I have all the voltage drops, I have the current. So this circuit is soft. I can't do anything else with it. Now I'll move over to this one to see what I have unsolved. So what I have unsolved is, I don't know the current in this branch, I don't know the current in this branch, but we know enough information to find the current in each branch. Find current, gotta know voltage, gotta know resistance, and then I can find those branch currents. We know that for each branch. I got 15 volts across each branch. It gave me the value of the resistors. So we can solve for that current. So let's do it. Well, for this first branch, I got 15 volts. My branch resistance is 6K. I got 15 divided by 6, which is 2 point what? 2.5. So I'm using blue for current. I'm going to keep using the same color for current. Go in the color code. And for this current, you get 2.5 milliamps. And right away, what I want to do is show it going into this branch. Another diagram, 2.5 milliamps. I come back over here. The only thing I have on left is this branch current. So I can solve. I got choices now, don't I? I can do it the same way. I can say I can take 15 volts over 2K to get the current, or I got 10 milliamps going into node A, and I got 2.5 coming out. I know that this branch current and this branch current has to equal the total current, so I can do a subtraction and get it. So either way you want to do it is okay. What is that? 10 would be 8, 7.5. This will be 7.5 milliamps. I did my subtraction correctly. And this right here, 7.5 milliamps. I look at this circuit, I notice I have all my voltage drops across each resistor. I got all the current through each resistor. This circuit is solved. So now I move to the next one and say, all right, what am I missing? And the only thing I'm missing that I can see is I'm missing the voltage drop across R2 and R3. To find voltage drop, you got to know current, you got to know resistance. Of course, it gave us the resistance values, and we solved for the current value. It's a piece of cake. I can solve for the voltage drop across both those resistors. So to find the voltage drop across R2, it's just going to be the current 2.5 milliamps times the resistance, which is 2K. And what I said is if you have the current in milli and resistance in K, you can just kind of ignore those and go 2 times 2.5, which is 5 volts. So I got 5 volts across R2. So again, using my red marker, I'm going to show 5 volts across that resistor. And now I can do the same thing. I can multiply the current times this resistance if I want to get the voltage across 3. There's an easier way to do it. What's another way I can get the voltage across R3 without doing any multiplication?
Kirchhoff's law.
Kirchhoff's law. If I have a voltage across this branch of 15, and I have a voltage across one of the resistors in the branch of 5, then this has to add up. The voltage across this resistor plus this resistor's got to add up to 15. Therefore, the missing voltage has to be 10 volts. I stand back and look at the circuit. I see I have all the voltage drops across each resistor, current through each resistor. This circuit is solved. The only thing I can ask here on the quiz, exam, test, whatever, will be for power for the resistor or power for the total circuit. If you remember, power is just current, voltage, the product of voltage and current. You see, we know voltage for each resistor, voltage drop, and we know current for each resistor. I can get power if I want to get power. So the circuit is solved.
So is the voltage drop across R4 15 volts?
It is 15 volts.
Okay.
And the reason it's 15 volts is because it's connected to a node. And remember, a node voltage, that means anything connected to that node gets 15 volts. Now, don't be confused. R2 doesn't get 15 volts because that branch resistance is equal to 6K, the total branch resistance. But the total branch resistance, you can see from this diagram, does get to 15 volts. So yes, R4 gets 15, and the combination of R3 and R2 in series gets 15. That's exactly right. So hopefully, guys, you can see that this is a really, 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 really good method for solving circuits. And the more pictures you draw, I mean, I don't have a lot of space on the board to draw pictures. The more pictures you draw, the less you got to think about it, because the circuit kind of works itself out. It's kind of like putting together a puzzle. And after a while, you even start to enjoy this stuff. I don't know about you, but I kind of like doing this stuff. So anybody have any questions over any calculations or concepts or approaches that we've talked about so far? Any questions? Okay, well, here's what I want to do now. I guess I got enough time to do it. I want to show you another problem where it's kind of hard to see what's in series with what and what's in parallel with what. So I don't think I have this document on Blackboard. I'm gonna put it on the board and I'll upload it to Blackboard for you. But I want to show you a problem that you look at and you're going to be like, well, I don't see how these things are connected. I want to show you a technique for solving a circuit that might not at first be easily recognizable what's in series and what's in parallel. So again, I don't have the document on Blackboard. You can just draw it, and I'll upload it to Blackboard a little bit later, probably later today. So I'll draw it, and you see what you can do with it. See if you can figure it out. I'm actually going to draw it on that side of the board. Let me find it first. I'm going to draw it over here. And you'll see why I'm drawing it later. I had a little mark down here so I know when I was out of my camera, but I guess I erased it. Anyway, I'll try to just stick it right here. All right, here we go. All right, so you're drawing this circuit. I don't know if I'm writing too small or not, but you have R1, R2, and R3. That's a 3, that's a 5, that's an 8. 3, 5, and 8. And then this one is R4. It's a 9. This is R5. 2 is a 9. This right here is R6. It's an 8. My voltage source is 24 volts. All right, so that's it. Look at this circuit and see. Can everybody see it? I guess you guys can see the values. See what you can do with it. See if you can give me the voltage across each resistor, current through each resistor. I'm going to give you maybe 5 minutes to just kind of think about it and play around, doodle, and see what you would do with this. And then I'm going to show you a technique that makes this, that greatly simplifies the circuit. I'll show you a way to to approach the problem. I want you to try it first. So I'll give you about 5 minutes to try it, and I'll give you one hint on this. I suggest you redraw the circuit. That's what I'm going to end up doing, is redrawing the circuit. So I suggest you redraw it in a way that makes it look more visually pleasing. I'll leave it at that. So see what you can do with it, and I'll show you my approach in just a couple minutes. Give you a couple more minutes, and I want to show you a way to do this problem if you haven't figured it out. Some of you have already sent me your attendance. If you haven't, go ahead and text me so I'll have the attendance. Okay, so here's what we're going to do here. Now, you might have solved this. I don't know if you guys figured it out or not. But let me show you a way to make this a little easier to look at. And that's all it is, just how you look at this. So the problem is these resistors here. I mean, the way they're drawn is just kind of hard to see, what's in parallel with what, what's in series with what. So what you want to do is you want to draw resistors not at a diagonal, not at an angle. You either want to draw resistors horizontally like this one or vertically like this. So to get the diagram that I want that's easy to view, that's easy to look at, what I'm going to do is I'm going to shade in all the nodes. Now, normally I use one color for nodes, but here I'm going to shade in, give each node a separate color, because what I want to do is I'm going to use those colors to help me draw the resistors the way that's easy to look at. So it's easier for me to show you than to explain it. So here's what we're going to do. See, I have a node here. Remember, a node is a connection of 3 or more wires that cut a circle or shape. So what I'm going to do, though, is I'm going to draw the node. I'm going to draw the node all the way out like this to see what resistors is touching. So like this node right here actually extends all the way over like that. So I'm using green for that. I got a node right here, a small one. There's 3 wires. If I draw a circle, we'll cut that circle with 3 points. So I'm going to use purple for that. So I got a node right here. And then I got another node. It's kind of hard to see, but this is actually at the bottom. I can draw a shape like this. I'm going to try this blue. I don't know how well this blue is going to show up. I got a node like this that touches R3. It comes up here. It touches R6. It touches R4. It touches R5. So there's another node. I can draw it all the way up to there if I want to. So see how I kind of drew it? It's kind of funny the way I drew it, but I just want to kind of exaggerate the node to emphasize what resistors touching which node. So now what I'm going to do is I'm going to draw these nodes. I got a green one, that color is purple, and this is blue. I'm going to draw those over there, but I want to stretch them out. So here's what I'm saying. I know I got a green node, so I'm going to draw just a green line. I have in the middle, well, let's go. I got a blue node at the bottom, so I'm going to draw a blue line. And then I got this purple node right here, so I'm going to draw a purple line. Now the purple node is in between the green node and the blue node. Over there, I'm going to extend it out, draw it as a line, but I'm going to draw it between the green node and the blue node. So my purple node is right here. It's a small one, so I'm just going to make it like that. So there are all my nodes over here represented as lines. And then what I'm going to do is I'm just going to kind of check off. I want to draw the resistor over here. I can only draw a resistor horizontally or vertically. I'm going to draw it over there. I'm going to check it off between which nodes it's between. Like, for example, R2, the top of it connects to the green node. The bottom of it connects to the purple node. So I'm going to draw that over there. So let me just draw it. R2, the top of it connects to the green node. So the green node is right here. R2 connects to the green and to the purple. That's R2. And it is 5. And then what I'm going to do is just for me, I'm going to check this one off. I'm done with that one. I'm going to see, do I have anything else between the green node and the purple node? Well, looks like that's the only thing I have between the green node and the purple node. What about between the purple node and the blue node? Between the purple node and the blue node, I see I got R3 and R6. Both of those are connected to the purple node, and the other ends are connected to the blue node. So I'm going to draw those over there, but remember, I'm not going to draw them at an angle. I can only draw them straight up and down or horizontally. So R3 connects between the purple and the blue. So I'm going to draw R3 over here between the purple and the blue. And it is 8 ohms. I'm done with that one. R6 is connected to the purple and the blue. So I'm going to draw R6 between the purple and the blue. It's horizontal. I'm going to draw it straight up and down. So R6 is between the purple and the blue. So here's R6. It is 8 ohms. So check that one off. I don't have anything else between the purple and the blue. Now, the only thing I have left is I got R1, which we'll get to that in a second. I got the green node and the blue node. What resistors do I have between the green node and the blue node? Looks like R4 and R5. Both of those resistors go between the green node and the blue node. So I'm going to draw those in here. Both those resistors between the green and the blue. So I got one here. And that is R4. I got one here. And that is R5. R4 is 9. R5 is 9. So I got a 9 and a 9. 9 ohms. 9 ohms. And I check those off. And now I observe that I got every resistor up there except for R1 and the voltage source. Look at R1. R1 connects to the side of this green node. So R1 over in this diagram, R1 is like right here. And it's 3 ohms. And then the voltage source connects between R1 and the blue node. So I'm going to go ahead and stick that over here. The voltage source is over here like this. And it is 24 volts. I'll just put it right here. So if you look at, you can clean it up a little bit and cut the wires off, make it look nice. But compare this picture to this picture. It's as clear as day over there. What's in series with what, what's in parallel with what. You can clearly see that R3 and R6 are in parallel. It might not be so clear over here. You can clearly see that R4 and R5 are in parallel. Again, it might not be so clear over here. It's probably more clear since you can look at this and look back. But if I look at that, I can do this problem all day. Now we can apply our method of combining this down to a series circuit and then working back to solve it. So we got about, well, I'll tell you what I'm going to do. We only have a few minutes. I'm going to continue to work, and I am recording this. I'm going to work. We go past 10 o'clock and you guys want to cut out, that's fine. I'm going to record the video. And you can look at the video. But before I do that, a couple things I want to say. In lab, I noticed that you guys are not reading I shouldn't say you guys. Some of you are not reading the lab. So you come in here and you don't know what to do, and you're kind of dependent on me to tell you what to do. You want to make sure that you read the lab before you come to the lab. You're familiar with what's going on, because I'm not going to sit next to you and kind of say, connect this up and do this. You got to try to figure it out yourself. I got to kind of wean you off of depending on me to kind of tell you exactly everything to do. You got to be able to take a technical document, read it, understand it, and then implement it. So you got to be able to read the lab, understand the lab, and then build the circuit and proceed to implement the lab. You got to be able to do that. Now, if you get confused, I'm here to help you. But I don't want to just tell you every step of the way when you got the procedure right in there. So taking the labs in order, I think we did experiment 4 was Ohm's law. So I think power is the next one. So whatever that number is, make sure next week before you come to lab that you've read it, you've understood it, and then we can when I go over it, it'll make more sense. I'm going to continue to work this problem, but I know some of you might have to cut out. So let me open this up for questions and see if you have any questions before I proceed to work the problem. Anybody have any questions over this or any questions in general that you need to ask me before I get into the problem? Any questions? Okay, well, here's what I'm going to do. These two circuits are exactly the same. I just redrew it so it's easier for me to look at. So I don't need this anymore. So I'm going to get rid of this. I'm going to work off that. That now becomes my original circuit. So I can get rid of this. Now I'm going to have to redraw this circuit several times. So I'm going to probably be everywhere on the board because I don't have a lot of room here. Hopefully we can fit this in. We'll see. And I'm going to, I don't know, I'm going to probably use this red for my nodes. So I got the other colors I'm using already. So here's a node. Call that node A. Down here we got this bottom node down here. Call that node B. And I'm going to redraw this. Now I'm going to do a couple pictures, but I want you to go ahead and you start drawing circuits. Now you can skip some steps, like if you want to combine these two and combine those two. I mean, the more steps you skip, the more thinking you have to do. The more pictures you draw, the less thinking you have to do. I'm actually going to skip some steps. Only reason I'm doing it because I only have enough space over here. But if you can see the whole board, I would first combine these and then redraw it. And then combine these and then redraw it. And I would do it, but I don't have enough room to do that. So I'll combine some steps and then we'll figure it out. But you go ahead and start combining stuff, and I'm going to start combining stuff, and we'll just kind of work this thing out. So I'm going to start up here and then probably go down here. See if I can make this fit. I don't know if I can make it fit or not. So you go ahead and work it. We'll compare answers in just a second. Okay, so normally what I would have done is I would have combined these and then redo the circuit. And actually, I combined these right here. This right here is R4 parallel R5. 9 parallel 9 is 4.5, so this is 4.5. But normally I would draw these like this and then leave this one like this, but since I don't have a lot of room, we'll go ahead and combine these two. If I take 8 parallel with 8, I get 4. So this one right here is R3 parallel R6. You do that, you get 4. So study this and make sure you understand how I went from this diagram to this diagram. This resistor is just these two in parallel. This resistor is just these two in parallel. So I'm going to move my, and I got another node here too that I forgot about. I got a node right here. Should shade that in too. Since that's A, B, I'm going to call this one node C. So put that on your diagram. So when you look back at this, this makes sense. And then when I move my information over, I see right here, I got A down here. I got B, and then right here, I got C. Now, I'm going to pause a minute. You kind of can see where I'm going with this. And so I know some of you got to leave because it's after 10. I'm going to keep the camera rolling. You can go back and look at the video. I want to pause a minute. If you see how I went from here to here, I want to pause because I want you to get ahead of me in your calculations to see if you're doing it the right way. I don't want to kind of lead you. I want to see if you're doing it the right way. And then if you make a mistake, that's when learning takes place, when we correct the mistake. So don't be quiet for a few minutes. You keep working with this. Go to the next circuit. In the next circuit, you'll combine this one, and then you'll have two resistors in parallel. Then you'll do one more to get the series circuit, and then we'll work backwards. I'm going to give you about maybe 2 or 3 minutes to go to the next circuit, and then I'll be back on it, and then we'll work it out, and then we'll call it a day. All right. So I think I'm gonna come down here, work this. So so I can combine these two. When I combine these two resistors, I get this circuit. I turn my audio back on. Let me see. Sometimes I forget to unmute my mic. Yep, I'm unmuted. Okay, so I'm gonna draw the circuit. This is a 3. I'm gonna combine these into one resistor. They're in series. I'm gonna add them, and I'll get a 9 ohm resistor. 9. Now, if I want to name it, here's how I would name it. I got this resistor, which is called R3 parallel R6. Since that's one resistor, I'm going to put it in parentheses so it mathematically it represents one resistor. I got it in series with R5, so series is always a plus sign. Plus R5. It doesn't matter which one you have first. I would actually write this here, but I don't have enough room to write it, so I'm not going to write it. But I got that 9 ohm right here, which comes from here. And then I got this 4.5 over here. And I got my 24 volts. The nodes look like this. I got A. I got B. Notice C disappeared. It's inside of here, so I don't have to draw C. I got one more step to get down to a series circuit. Combine these two in parallel, and I end up with what I want, a series circuit. So I'm going to redraw this as a series circuit. And okay, I lost my line, so I don't know when I'm out of the camera. I'm going to scrunch this in here though. I got this resistor, just that one. These two are in parallel. So I need for somebody, anybody still out there, I got 9 in parallel with 4.5. Anybody have that number?
Three ohms.
Oh, that's nice. 3 ohms. That's a nice number. Then this is 24 volts. So see how we turn this complicated circuit basically down to this. And if I wanted to, I can add these two together because the voltage source, that 24 volts, doesn't know anything about any of these resistors. That voltage source thinks it's hooked to one resistor that has a total resistance of 6 ohms. It doesn't know anything about how many resistors are connected up to equal to 6. It just knows it feels 6 ohms of resistance across its terminals. So we're going to now solve this circuit. And I'm going to kind of move quickly here because I know you guys are busy. We're going to solve the circuit and just kind of go back and solve all the other circuits. We'll do that kind of quickly. So right here, I got a series circuit. To solve it, I find my total resistance. This plus this gives me 6 amps or 6 ohms. I use that to find my current. I want to find current. Current is equal to voltage over resistance, and these are totals. So my voltage is 24. My current is going to be 24 for my total resistance, which is 6. That's going to give me 4. I got 4 amps flowing out of the battery. That's my main line current, 4 amps. I'm going to show that. I'm hoping this blue shows up. I'm going to show that 4 amps coming out of the battery. But you got to show that in every diagram. When I'm grading you on this, I'm looking to see, did you color code? Did you put the same information in every diagram? Not just if you got the right answer, you're doing it the right way. So make sure you do this in every diagram. And the the voltage here is easy to get, isn't it? Because I got two equal resistors across a voltage source, so each has to get the same amount of voltage. This has to get 12, and that'll get 12. I don't even have to add it up. Now I forgot over here to put my nodes here, because remember, my node A is like right here. My node B. You don't want to forget those, because when I have a node voltage, that means I got things in parallel that's getting the same voltage, and that's what I have right here, a node voltage. So I'll use, I guess I'll use the green for my volts. I got 12 volts here across this resistor. So I'm going to show that in every diagram. I got 12 volts here. This 12 volts is a node voltage. I got 12 volts to go node A to node B. So over here, I'm going to carefully draw it between node A and B. And in this diagram, that means both this resistance and this resistance get the same voltage. They get 12. And over here, between A and B, is 12. And over here, between A and B, again, there's 12. So in this diagram, you see that everything connected between the two red nodes gets 12 volts. 12 volts isn't over here, right? It's between these two red nodes. I'm looking over here, and it looks like this circuit is solved. I'm going to move to this and see what I'm missing. And what I'm missing is the current here and the current here. To get the current here, I got 12 volts divided by 9. Anybody know what that is? What's 12 divided by 9?
1.33 continuing.
Okay, so my current here in this branch, 1.3 with a line over it. I'm going to show that current in every diagram. Over here, this is flowing into R2, so be careful. Show that going into R2, that 1.3 repeat. And then this would be 2.7, is that right? I think that's 2.7 amps in this one. That'll give me, yeah, that's 2.7. So this gives 2.7 amps. I'm going to show that 2.7 is probably repeating. And then now, look right here. This is important. This 2.7 is actually divided. I have R4 and R5 in parallel. Since they're the same, I got this 4.5 between these two resistors in parallel. Since I'm getting 2.7 amps in this resistor right here, the way I'm going to show it over here is that 2.7 is going to be equally split because both of these are the same. 9 parallel 9 gave me the 4.5. So each one of these is going to get half of the 2.7. Now you might say to yourself, okay, well, what if these were different? Well, then you'd have to use some math to solve the current. You know, you have 12 volts divided by 9. And then we 12 volts divided by whatever the other resistor is. So you know enough to get it, but I'm just using kind of logic and reason to say, well, if I got 2.7 amps going into this equivalent resistance, since that came from two equal resistances in parallel, each one's going to get half the current. So what is that? That's going to be 1.35? Is that right? What is it?
I think so.
Let me see. I'm trying to do this math in my head, but I'm not good at that. So I got 2.7 by 2, yeah, 1.35. So this gets 1.35 amps. And this gets 1.35 amps. And I'm still working over here. I got these 2 branch currents. The only thing I don't have in this circuit is a voltage across R2 and this resistor down here. I know current, I know resistance. I can take the product of this times that to get the voltage drop across R2, and then I can do the same thing across the 4 ohm if I want to. So what is that? I got 5, is it 6.5? Trying to do this in my head. I think it's 6.5. 1.3 times 5. Yep, 6.5. So I got 6.5 volts across R2. I got 6.5 volts across here. And right here, 6.5 volts across this resistor. And now to get this one, I can do the same thing. I can multiply 1.3 times this, or I can say, if I got a total of 12 across here, I got 6.5 across here, they got to add up to 12, so this has to be 5.5. So got to add 12. So I know that this is 5.5 between node C and B. So right here, I'm going to draw 5.5 between C and B. And I see I got all my voltage and currents on this one. I move over here to see what I'm missing. And all I'm missing is the current in R3 and the current in R6. That's really easy because I know the current going into node C is 1.3 amps. Since these resistors are the same, that 1.3 amps is going to split equally. Only a half of that. Now, you might say to yourself, like before, what if these resistors was different? Well, that's okay because you know the voltage across node CB. You know the voltage across both resistors. You know the value of both resistors. You can use Ohm's law to get those currents if they were different resistors. But since they're the same, we just take that and divide it. So it's going to be half of this is what is that? 5 point. I can't do it in my head. Probably could, but I got in a hurry now. So
6.8 or 0.68.
0.68. Okay, so I'm using blue. So somebody said that this current, 0.68 amps. This current, 0.68 amps. And now, as I always say, the only thing that we don't have is power. But you know, the voltage and current for each resistor, you can give me power. So now you understand why color code. Look at this. I mean, look at all of this. It's just really busy. If everything was the same color, there'd be no way I could grade that. I mean, it would just look all just kind of meshed together for me. But when everything is solved, I can see my voltages are in green. I can see those clearly. If I want to look at currents and look at boxes in blue, everything is clear when you color code. So that's it. So I showed you several methods of solving series parallel circuits. I want to do some more of this. What I want to do is the next step is, well, what if I have a circuit like this, but I don't know the resistor, maybe 3 of these resistor values, maybe I don't know that one or that. How would I solve that circuit? So I want to look at that, and then once we understand how to do that, then what we're going to do is we're going to say, all right, well, what if I put a voltage source right here? I want to put a voltage source right here. How would I solve that if I have like multiple voltage sources in the circuit? How would I solve that? And that's a whole nother story. That's kind of where we're headed. So the idea here is I'm going to give you guys a couple problems, but you really need to practice this way more than what I'm giving you. Guys, thank you for some of you for sticking around with me. I know I went over, almost 20 minutes over. So I appreciate you hanging in there with me. I see Daniel, Jonathan, Clark, Mohammed. You guys stay with me, so I appreciate it. Anybody have any questions before we sign off? Okay, well, guys, have a great rest of the day. Today is Wednesday. I'll see you on Friday, and then we'll be back at the weekend. So stay safe, and I will talk to you later. Thank you, Mohammed.